Hi everybody. Okay, so I thought I would make a video of the problem I'm having with some AC circuit I want to build. So we all know controlling a DC motor with some sort of speed controller is it's not difficult. There's a lot of circuits out there that you can put together, and they're fairly easy. It's a DC motor is just very easy to control. So, but what happens if you want to control an AC motor or some AC appliance? So for weeks now, I've been trawling the internet, looking for solutions. In my specific case, I've got a home-built bandsaw, and from my father-in-law, I got a induction motor. And one thing I must say, as soon as you connect this thing to an AC source, it just spins like crazy. So I was looking for some sort of soft start circuit that would start it slowly and then work its way up to full speed. So, I mean, there's a lot of circuits where people try to control some sort of AC load. And I think the most common one would be this one, which is you can find this in drills and all kinds of AC in power tools, and it's very basic. It contains just a few electronic components, and they tend to work very well actually. You can set your low voltage and your full voltage with a pot, and I must say I've tested this one with a light bulb and it works. And then I put it on my induction motor that I want to use on the bandsaw, and and the resistance on that motor and everything that goes with it is this thing just cannot start it up. So I was trolling the internet, and I mean there's a lot of circuits out there that can control a light bulb, 115 volt AC or 220 volt AC light bulb. And I mean that's even this circuit that I've got here could control the AC, the light bulb. And these circuits would normally start at about 115 volt, or if you're on a 115 volt source already, probably half of that, and then cover it till it's like up to 220 volts. So those circuits do work, and there's also a couple of circuits out there that uses Arduino microprocessors that you just program. Those I couldn't get to work, but I'm sure they do work. I've seen some videos of them working. I was just about to give up when I actually found a circuit that's, or let's just say rather found an integrated circuit, or as IC as they would call it, that was made for controlling AC motors or induction motors, or like they say shaded pole motors. And I found this circuit and that uses an LS7311, and there's a couple of those chips around with a one of the biggest difference between them is this one uses actually hard contact buttons, and where the other one which uses like just a touch button. Now, before I just ran off with this, there's the author, and I'm not sure if this is the designer of the circuit, or if he's just the author of the actual document, but if there are credits, that must go to him. A guy called Rajguma Sharma, I'm not sure if I got that right. And also he's got a site that's 2volt.com and electronics-lab. And this circuit, by just searching for the actual chip LS7311, you can find this circuit on Electronics Lab and on 2volt.com. And I think 2volt.com actually belongs to this author. So I thought I would give this circuit a try because the chip is dedicated to controlling AC loads, especially motors, that as they claim in the document. Now, in the document, the PDF file, there's also a circuit board that's it's readily made, and you can actually, like, whatever way you do your circuit boards, you can just go that route if you want. I actually first wanted to see if the circuit works. So I just used some VeraBoard to lay it out and to see if the circuit actually works. Now, in my case, or let's just say according to the document, the PDF document, it's got these values of all the electronic components that goes with a circuit. Now I just want to, before I do anything else, I just want to show you the circuit that I've put together. And it's just straight copper tracks, as you can see. I believe it's called VeraBoard, I can't exactly remember. Doing the circuit this way takes a lot of time because you've got to cut some of the copper tracks. But eventually, yeah, I got the whole thing laid out. And I have to say the circuit didn't want to work the first time. And I actually got it to work partially by using a light bulb, but the light bulb didn't want to switch on and stay on, rather stay on. Let me rather just say it didn't want to stay on. Now this circuit has got some power levels that you set before you press the run button, and it would keep a certain power level. Now I'm gonna go over now why the circuit didn't want to work in the first place. Now I'm not sure if anybody else that built the circuit actually got it to work, because I just could not get it to work. I was convinced this section was correct. I didn't get any shorts, nothing blew up on switch on. So also in the PDF document that you get that goes with a chip section, not from this author PDF document, but the PDF that goes with the actual chip. There is some application notes. If you're going to design a circuit using that specific chip, they've got some notes that you can actually go through, and they've got some values that they recommend. And they even have a circuit layout. And if you look at this circuit layout they have, it is pretty much in line with what this circuit looks like here. Now, after testing the circuit and finding that it didn't want to work correctly, I went back to the application note, and after reading it and going through the values that they recommend, I saw, this is the actual component list, I saw that they recommend, instead of C6 to be a 10 microfarad, they recommend a 220 volt microfarad unit. So that is exactly what I did. I took the 10 out, because when the 10 was in there, the light bulb would switch on and off immediately. And after replacing this to 220 volts, it was working as it should. So I thought, by going through the actual application notes, also C3, I changed C3, and also D1, I changed from a 4007 to a 4148, because the 4148 is as a fast recovery diode, where the one in 40007 is not. So if you're going to build this circuit, you should look out for C3, C6 and D1, because actually when I got the circuit to work, I burned out 2 components on this board because I was switching too fast between the different settings. So when that happened, I blew a resistor here, and I blew the chip actually. So after that happened, I switched to a fast recovery diode, which is D1 in this case. I just replaced the resistor because that blew because the chip got a short between 2 pins. The unit is fine, it works very well now. One thing, if you're going to build a circuit, I would just comment that if you switch from the different power levels, and especially if you're running an induction motor or some big motor, that you should not just run and press these buttons, but take caution in switching from low all the way slowly to high, and then maybe, you know, just take time, don't just press them quickly, because I mean, as the circuit is now, it might work better with the fast recovery diode I've got in there. I'll also change the cap, which is C3, from a 0.1 to a 0.47, so I'm not sure if that'll make a big of a difference, but I can say the circuit actually drives the induction motor I have. It would not start the motor up from the lowest setting, but somewhere up the line the motor would start and it would run up to full speed. So if you're going to build this circuit, I am just saying read the application notes and see what I recommend, because C6 as a 10 microfarad will not work, not even if you have a light bulb in there. I only got the circuit to work with a 220 microfarad capacitor in there. That actually made the circuit to work for the first time. And just stick as close as you could to the other values. If you don't think anything is right, go to the application notes of the chip manufacturer. This is not going to be very clear on the camera, but they'll give values in the notes, and this is where I got the correct values from. As you can see here, C6 is their recommendation, and they also have a recommendation for some other parts, but I have not changed it. I think the unit as I have it now will work pretty well. And I'm just going to say again, the circuit is the work of the author, and I believe the document he put together, and it's also his design. I'm not sure, but you can find the circuit and the PDFs on these 2 websites. And if you're going to build it, you can go ahead and do it. Just make sure the components, and I'm just going to show you here, make sure the LEDs as well are small little LEDs so that they don't draw too much current. On the application notes, I recommend, they have a recommendation there, but the smaller the diode, the better, the LED, sorry. And like I said, the 10 microfarad that sits here is not correct. It will not even start a light bulb. Bump that up according to what the application notes say, but a 10 A 10 might work if you're on a 115 volt outlet, AC outlet, but if the circuit doesn't work, you've got to turn your attention here. And if I remember correctly from the application note, if you on a 115 volt AC outlet, C5 also need to be 100 microfarad, so a 10 is completely wrong here. And just replace D1 with 4148 instead of 4007, so there's faster recovery time. BTA 136, I've used something else that's got more amps, but it depends what you've got available in your country. And like I said, don't push these buttons too quickly once your motor's running, because you might blow something, but you've got to experiment. But like I said, I got it to work, and it runs my bandsaw motor. And just do those changes if you want this to work, and I'm sure everything is going to be fine. Okay guys, thanks for watching. Cheers.